Hello and welcome back to my Polyglot Developer Twitch stream. So we're a few episodes in when it comes to streaming on this particular channel. We've done a variety of things from video editing to see how I do video editing for each of the YouTube videos, to React development, to podcast editing, and even native script mobile development. So we've had a good run so far. Given that this channel is so new, you can kind of expect that there could be problems at some point in time. Maybe the audio is got an echo, or the video has some spasms. Trying to figure things out. Each stream hopefully gets a little more better than the previous stream. Also take note that because everyone is, a lot of places are shelter in place, like where I'm at in California, the internet can be very congested. So if my bandwidth starts to stutter, if my download and upload rate go crazy, the stream might have to be cut a little bit premature. Hopefully that doesn't happen, but you never know. This stream is live, so please engage with me in the chat. Locke, thanks for joining. This is meant to be an interactive experience. It's supposed to be a little informal, a little laid back. So, for example, tonight it's 7 o'clock over here in the evening. I'm just going to do some Go development. I get a lot of these questions when I'm out at meetups and events, not around what I'm doing at those particular events, but more so, how do I get it into Go? So, I mean, a lot of people have heard about Go. They've never actually had hands-on. So they're more or less interested in how to get started. So that's kind of where I want to go tonight. Maybe we'll do about 30 minutes to an hour, see where things go. We'll get the basics, the ins and outs, and then maybe in a future stream we focus on something a little more complex, like a real application. And just kind of for disclosure, definitely not a pro Go developer. The stuff I use it for is probably insignificant in comparison to companies like Docker and Minio, and I don't know. There's a ton of organizations using Go. I'm hardly scratching the surface in comparison to what they do on a daily basis. All right, so let's jump in. So if you've never installed Go before, there's numerous ways to do it. I've seen people try to use Homebrew if they're on a Mac. I think you could even get it with Chocolatey on Windows. I actually recommend that you just go ahead and download it from the Go website. The last time I saw somebody get it with Homebrew, there was all kinds of problems. I don't know why. I don't know if it was a one-off thing, but I've downloaded it directly from the website, and it's never failed me yet. So when you install it, whether that be on Mac or whatever you're using, you can first what you have to do is you have to set up the Go path. So the Go path is just an environment variable on your computer. So for example, my Go path is this. Yours, of course, can be wherever you want, but it does need to be set. So if I navigate into it, it'll look something like this, and I'll open it in the Finder. Is this for anyone who's lingering around in the chat? Is this too small? Should I stick in the terminal? I'm not sure if I can zoom in on the Finder window or not. It's all right. I will switch back and forth just in case. So basically, this is what I have in my Go path. This is what you'll get when you first try to use Go. The bin directory is where you can install Go packages or Go applications that you wish to use. So for example, I've installed this application called Error Check, so that way I could use it in my own applications. It's not like a package that you can import. It's a package that you can use. So this is a binary. This is a built application. You have different packages that you can make use of, and then you have your source code directory where all of your projects will reside. I think I'm not using the most recent version of Go, so I'm using Go version 1.3 or 1.13. I think we're on 1.14. From what I heard, at some point in time, they're going to be making it so that way you don't necessarily have to maintain a Go path like the one that I'm demonstrating. So that way you can just have your projects anywhere. I've never experimented with that yet. I've always stuck strictly to this Go path, and I've followed the naming convention that that's been used up until recently. So for example, all of my projects would appear in source, the GitHub folder, and you're basically creating a namespace here, and then Raboy. So any project I wanted to create in here, it kind of mimics what I'd see on GitHub, for example. It doesn't have to, but in this case, it does. So let's go ahead and create a new project. I'll say let's call it Twitch. This is where we're going to work off of tonight. So I'll go ahead and navigate into it. Where am I at? Source, GitHub, and Raboy. So this is my path with so it's inside of my Go path. I'm also going to navigate into Twitch, and I'm going to create a new file. So I'm just going to call it main.go. And please, if this is meant to be kind of just a getting started with Go, if you're in the chat and you have a question, please ask it. I want you to feel like you can jump into Go by the end of this stream and be able to fiddle around with it and be prepared for whatever I stream about next. So let's go ahead and open that. I'm going to actually do this in Visual Studio Code. So I have my Go file. I'll zoom in a bit. If this is too small at any time, I can always zoom as some more. But what you would typically do is you would define a package name. So this is my main, and you'd have a main function. This is, oops, that's not a correct function. It has parentheses. So this is kind of the basics around a Go application. So it's kind of like Java, where you have a main function in Java, even C and C++. Less so if you're familiar with JavaScript technologies, you don't really have to worry about main functions. But this is kind of the core driver file, and you can always create additional folders inside of this project, and those files wouldn't have main functions, but you would have one main function for your project. One thing I do want to point out, and this is going to make a world of difference when it comes to Go development. So if you're using Visual Studio Code like I am, I actually recommend that you take a look at the Go extension. So there's a Go extension. It's a Microsoft plugin here. This plugin, if you were to try to do Go without it, it's possible. You're not going to have a very fun experience. But if you install this, it does quite a bit. You get IntelliSense, so you get the type ahead. It does some error handling. If you start writing test files, you actually get it'll actually do code coverage for you, and you can set it up to run your tests on save, all kinds of good stuff. Awesome. Thanks, Locke, for sending out that tweet. I just got it on my watch. So again, if you're using Visual Studio Code, I don't know if people are still using Atom. There's also a similar extension for Atom. Maybe you are wanting to use Golang, which is the JetBrains IDE. It's up to you. Definitely use something that's designed for Go. Otherwise things can get tough. It'd be like kind of like doing Java development without an appropriate IDE, or even C++, C, when you have to manage a lot of different packages. It can get messy. So I'll close this. I'll go back into my my Explorer, and we'll get started here. So first of all, I have my main function. Let me open up a terminal inside of this Visual Studio Code. And again, if it's too small, let me know. I want to make sure that it's visible. But if I were to run something like go run, and then the file, which is main.go, nothing's going to happen, because it just runs this main function, and it's not doing anything. So it's to be expected. So if I wanted to do something else, so let's say I wanted to print something to the console, I can say fmt print or print line, or there's different variations. I'll walk through a few of them, and I'll say hello world. I hit save. Now you'll notice that it imported this fmt package. It did that automatically because of my plugin for Visual Studio Code. Like I said, install that plugin because as you start developing, you're going to end up with a lot of different imports, and you don't really want to have to do that on your own manually. So I did an FMT print line. I can say go run again. And this time it said hello world. So nothing terribly exciting, but we're on our way to the full Go experience. And let me just, for the sake of it, so that way we have some record keeping going on, let me paste the Go URL into the chat, so that way in case people need to download Go. I have other links that I'll share as well, and I apologize if I know it could be late where you're at, and me switching between light and dark screens could be blinding you. I apologize. But let's go back into Visual Studio Code. Locke is saying, is a main package and a main function always required? If you want code that runs, and this is to my knowledge, I could be wrong on this. If you want to be able to run your application, you would need a main function. But if you're developing, say, a library or package, you shouldn't need a main function. So there's plenty of people who are developing plugins and extensions and things like that. And then you would just import them kind of like you would any other language. So they're meant to be helpers. As far as a main package, I do believe that you need a main, again, I think they come hand in hand. I could be wrong. If anyone is doing Go development and watching in this chat and you know a definitive answer, please let me know. Yeah, see, I did a hover over. This is, again, a nice feature of the extension. So let's look at a few other options here. So let's go ahead and say FMT dot, let's go ahead and say printf. So this would be printing a formatted kind of string. So for example, if I wanted to say hello, and then maybe percent, and there's tons of different options. I usually just use V for, I think it's value, but I think there's like S, and it depends on the data type that you want to use. I'll do a new line there because it's just a standard print. And then for the value, notice that it was comma separated there. I'm just going to say world again, and I'm going to save it. So I'm going to say go run main.go. And you can see that I did hello world twice. So this printf is nice if you want to print variables or if you want to do a formatted string. Another tip that I have for you, if you want to run your application very easily, maybe you don't want to specify the file that has your main function, you can just say go run *.go. It'll accomplish the same thing for you. Now let's say we want to build this. This application's not exciting, but you probably don't want to just run it manually from the terminal every time. So what you would do for distribution is you would say go build. And what it'll do, you'll notice that inside of my Explorer here, it created an application binary based on the parent directory name. And I could always provide it a name when I build, but I don't have to. So if I wanted to run that binary, I can say Twitch, and it accomplishes whatever we have in that application. Now, something to note, I'm on a Mac. I ran go build. That binary is set up for my Mac. If I were to send it to somebody who's running Linux or Windows, they would not be able to run it because it's not set up for them. If I were to send it to, if I wanted to, I could do this. So if I wanted to create a package or a binary that was suitable for Windows, I can say something like go OS equals Windows, and I can say go build. So what this did is it created twitch.exe, and this file would be Windows compatible. I could send it to somebody on a Windows machine, and they would be able to run it. Now let me throw out another example. Let's say I want to say go OS equals Linux, go build. So this Twitch file right here in this Explorer, this is a Linux build, and it'll work in the circumstance that if somebody's running a Linux operating system and they're matching the same CPU architecture that I am, then it'll work. if I were to say, give this Twitch Linux file to a Raspberry Pi and run it on the Raspberry Pi is running maybe Raspbian or some flavor of Debian, it won't work because the Raspberry Pi is running ARM as the CPU architecture, whereas I am not. So I can always accommodate that as well. So I can say, for example, Go OS equals Linux, and then I can say something like Go architecture equals ARM. I can even specify the version if I wanted to, but let's go ahead and say Go build. So what this did now is it not only built it for Linux, but it also built it for the ARM CPU architecture. So this is a nice feature of Go. For anyone who's built applications with C, C++, and you've ever had to do cross-compiling, it's nasty business. So you have to get all kinds of different tool chains installed on your computer. The setup is miserable. With Go, it's very easy to cross-compile, and these are compiled applications. Go is not an interpreted technology, so it's not like Python. It's not like JavaScript. When you do a build, you're building it down to machine code, and it's going to be fast, and that's why a lot of people like Go, because it's compiled. It's a binary. It's native. So those are some build commands. So let's let me look at the chat here. I am monitoring the chat back and forth. So if you have any questions, this is a new stream. I suspect that there won't be too many people watching at any given time, but that's all right. It'll get there. All right, let's get a little bit more complicated than just print lines and print Fs. Let's get into the realm of variables now, because variables it's a little different from other languages. So for example, let's maybe I'll comment this out for now. Let's say that I wanted to set a variable. Let's go ahead and say that I wanted to say we're going to do the hello again, but this world is going to be a variable instead of me typing in a string. What I could do is I could say, I don't know, I'll use data. Data is probably the worst variable name you can choose, but for now we're gonna keep it at that because I don't really have another name for it. So if I want to declare and set this variable with data, I can use :equals, and I can say world. Now, just in case you're coming from another language, there's no semicolons here. If you add semicolons, and you have the plugin installed, it'll just remove them for you when you try to hit save. You'll notice that I saved it and it added this underline to it. That's because I'm not actually using data. So if I were to try to build it, it's going to fail because it's going to recognize that I have variables that aren't being used. I don't know if you can turn that feature off. I don't know why you would want to, because it does help you maintain much better code. So if I wanted to, let's go ahead and say, again, I'm going back here and it's not terribly exciting yet, but if I said data, saved it, said go run main.go, I have hello world twice. So that's one way to set a variable. When I do it this way, I've not defined what type of variable this is. It just automatically picks up that's a string. That's one way to do business. Another way to do business is I can say something like var data string. So now I'm saying that this variable data is declared as a string. It doesn't have any data in it, so if I were to print it out right now, it'd probably just print out hello. So let's give it a shot. Yeah, so it says hello. So what I could do now is I can say data equals world. And you'll notice that this time around, I didn't include the colon. So I didn't include the colon because I've already declared this variable. I've declared it up here as data. If I hadn't, then I would need the colon because I am kind of initializing it with data. So if I ran it, again, it says hello world. And just to show you something else, let me comment this out. I'm going to go back to this first example, which was world. I can then say data equals Nick. So in this example, I've set it up with the colon, but because now this exists, I don't need the colon for further use of it. So I'm going to run it, and it says hello Nick. So that kind of got me when I was learning Go. This was very different from what I was used to. So just remember that if you've never used that variable before, you can either set it right away, or you can use var. And there's different reasons why you would choose each of those, and I'll be showing them as we progress. But for now, that's kind of variables in a nutshell. And you have all of the data types that you would expect. You would have they're slightly different. They're like int32, int64, string, different ways to look at it. So let's talk about arrays now. So we're going to look at arrays real quick. Then we're going to maybe look at custom data structures in Go. We're going to kind of evolve into functions. Just all of the basics when it comes to the Go programming language. Yeah, you would need the var keyword when you don't give it a value, and you want to assign it a specific type. An example on where you wouldn't want, or where you would want to use var. Let's say, for example, you are receiving requests from a web service, right? You want to declare your variable, and then when you receive the payload from the user, you would decode it into the variable. So it doesn't decode it on the fly. There's many other reasons as well, but that's just one that I use a lot, is decoding. But maybe we'll run into another example as we progress. So let's go ahead. Let me take off my jacket. It's getting a little hot in here. When I stream, my door is shut. My computer, it starts making jet engine sounds, so it gets real hot in here from Open Broadcast Studio, which is what I'm using to stream. So let's go ahead and let's look at arrays and how to use them. So let's go ahead and say var, and I'll just comment this out as well. We're gonna keep using the data variable name for a while until we can think of a reason to make something unique. So let's go ahead and say data. This is going to be an array, and this is going to be an array of string. So I save it. It's still being used. Let's go ahead and see what happens. So it printed out just an empty array. So let's go ahead and add data to that array. We can say, because we've defined the size of this array, we can say something like data 0 equals Nick, data 1 equals Raboy, and we won't fill the last slot, but let's go ahead and run it. So it's Nick, Raboy, and then blank, because index 2 is not being used. So that's arrays. If I wanted to, I can set it, or at least I should be able to set it like I think like I would any other language. I haven't actually tried to set it this way. Let's see if it works this way. So let's go ahead and say Nick, Raboy. It may not work. If it doesn't, that's all right. There's other ways that we're going to look at this. We'll come back to that. So that's an array, though. There's another thing that we want to get familiar with. We want to get familiar with a slice. So we've defined this as a size of 3. When it comes to Go, when it comes to C, C++, it's not really, you're not really able to change the size without reinitializing a new array. So in other words, you can't keep pushing to the array because it's going to get out of bounds. So in Go, there's something called a slice. So a slice is like a vector in C++. And it's actually a lot easier to define. So for example, I've now removed the size from this array, and now it is no longer called an array, it's called a slice. So it handles all of the sizing for you as your array expands. So it's very different. If you've defined the size of your array, that's going to be your size, and you're going to have to manually do a bunch of magic tricks to expand it. But if we're keeping it as a slice, Go is going to take care of that for us. But with that, I don't believe that we can actually do this anymore. We might be able to, but let's try. Yeah, it didn't work anymore because right now our array size is 0. So we can't just set indexes as of now. So what we have to do is we have to do something a little different. We have to do this. We can say something like data equals append. So append is going to take the slice that we were using originally and the data that we want to push to it. So this is just a push command. And we're pushing it right back into, so it's creating a new slice for us. So if we save it, and maybe I'll just do the same for one more. And let me turn on the light. It's getting a little dark. Let's see if that gives us, all right, looks a little better here for the camera. So I'm saving it. I'll run it again. And it worked this time. And I don't have that extra slot. There's no padding here because there's only 2 indexes in this. So definitely figure out what you want out of your variables. Do you want it to be an array or do you want it to be a slice? And then how you interact with them is going to be a little different. So let's create a native Go data structure. This is where things are probably the most useful. I don't necessarily find myself just creating slices randomly. I generally try to stick to a data structure. So for example, let's go ahead and create a data structure called person. And person, it's going to be struct. And we are going to define the fields inside of person. So we are going to define probably a first name. This is going to be a string. And we'll start with the last name just for now. So string. Now what we can do, and I'm just going to remove all of this. We're going to do some cleanup here. We're actually going to no longer be using data. We now have something that makes sense, you can say. We're going to say, let's go ahead and say person, if we want to define it this way, equals, and notice that this is a lowercase p, equals, and this is going to be person. So we can define it this way. So we can say first name, Nick, last name, Raboy. And if I saved it, it's going to yell at us because in Go, it does some funny business here where every line in a struct or array, if you separate it by new lines, you need a trailing comma, always. It's erroring out right here because we don't have anything that says data anymore. So let's go ahead and change this to person and save it. And let's go ahead and say go run main.go. So you'll notice that it's no longer an array. It doesn't use the square brackets anymore. It uses the curly brackets, but that represents the first name and last name. So for example, if I wanted to, I can say person.firstname, and it's just going to be a string now. So it's going to say hello, Nick. So that's one way, of course, to define, to make use of our struct. So the other way, of course, is to say var person, and this is going to be of type person. And I'm going to say person.firstname equals Nick, and person.lastname equals Raboy. So same kind of business here. It's just two different ways that we made use of the person struct. And please stop me if I'm moving too fast. I know that to some people, if you're an experienced Go developer, this may feel a little slow. But when I was starting out learning Go, I personally feel like this would have helped me to kind of get this kind of slow down version. All right, so we have person here. So let's make some changes. Let's modernize this maybe for what a lot of people are using it for when it comes to actual development. So in Go, when you have data structures, there's something called an annotation. At least I think that's the true naming convention for it. I've always called it an annotation. But it's basically, it defines how you want to map the fields of your data structure to a different kind of data type. And by data type, I'm referring more to things like a JSON field, an XML node, a CSV element. So it's direct mapping. So that way, when you want to convert between formats, you don't have to worry about doing it manually. Go will take care of it for you. So for example, let's go ahead and say that we wanted to map this to JSON. So I'm going to say JSON, and I'm going to say that this particular first name, it probably makes sense to map it to first name. It doesn't have to be. The JSON annotation does not need to match the name. Let's say that this JSON annotation is last name. I save it. It's going to yell at me because when it comes to annotations, you do need to export the fields. So to do that, we're now making them capital first letter. So Go, you'll notice that a lot of functions, a lot of variables, they start with a capital letter. That's because that kind of exposes them to other parts of your application. It changes the scope on them. So first name, last name, last name. Now things did change here. I'm saying first name, last name, first name. I'll run it, show you that nothing has really changed with the annotations and the capitalization changes. But you can start to do different things here. So let's say that I wanted to display JSON now. So Go has built-in JSON marshaller unmarshaller. It's going to take a look at our annotations here. So I'm going to say JSON, and I'm going to say let's go ahead and say Marshall. So it's going to expect an interface. An interface is kind of a high level. So a person is an interface, but an interface doesn't have any kind of rigid property definitions. But they're one and the same. So let's go ahead and take a look. So person is what we're using. And if I go back, so I'll say json.marshall just to show you the rest of it, you'll notice something interesting here. So in Go, and I don't know how many languages do this, but Go is the first time I've been exposed to it. You can have multiple return types for your functions. It doesn't need to just return one return type. So in this case, the json.marshall function returns a byte slice and an error. It doesn't mean that they both need to be set, but you could potentially have both of them coming back. So let's take a look at that. So one, I'm going to go back to data again. So I'm going to say data, comma, and then error. I'm going to use the colon because I don't have data defined anywhere. I don't have error defined anywhere. And each of those variables is going to store each part of the return. So because if I hit save, it's going to say we're not using these two variables. So one, we should probably check to see if there was an error. So we can say if error not equal to nil. And you'll notice that I don't have parentheses around this. Parentheses isn't really a Go thing. So if it's not equal to nil, that means that this does contain an error, and we should probably print it out. So if we wanted to, we can say fmt.println. It'll print it out. The thing about that is it'll print out here, and then it'll proceed to print out on line 26. So what we could do, we can do a few different things. We can say log.fatal. So fatal will print it out. We can say error. It'll print it out. You'll notice that it imported up here. Log. It also imported JSON. Log.fatal will terminate after it hits this point. So it'll never reach line 27 if an error was thrown. But that may not be what you want either. And technically, if you wanted to, you can say something like fmt.println error or print v or whatever you want, and you can say return. And in that case, 28 will never be hit either. That's probably not a very clean way to do business. There's also the option of doing a panic. So panic will still terminate the application. So line 26 will still never be reached. But I'll show you later, when you panic, the cleanup code that you implement is still ran. So any cleanup that you write for your function is still ran when you call panic, versus the log fatal. Log fatal will just terminate and no cleanup will be ran. And then likewise, the print line and then the return, I think the cleanup code will still run in that scenario. So it just depends on what you're after. So for us, we'll just leave it at panic for now. We're still getting an error because we're not using data yet. Let's go ahead and check it out. So we'll say data. It'll probably print out a lot of gibberish because it's a slice of byte. But let's take a look. So we have a lot of numbers there, a lot of stuff that doesn't help us at all. So this is a slice of byte. We can easily turn this into a string by wrapping it like this. So if I were to run it again, you'll notice that it's printing out JSON. So when I ran json.marshal on this struct, which is an interface, it is saying, give me the byte data of that JSON, which we are turning into a string. So it could be more pleasant to look at. It's definitely going to be more valuable if you're using an API because it's already mapped it. So if I wanted to, I can change this to, let's say, fname, because like I said, they don't need to match. So it's fname now. So in the application, I'm going to be using the fields as first name, but because of the mapping, it's going to be exported in a different format later on. But I'll just leave it as first name. I like to keep my variables kind of matching. Now, if I wanted to, and this is more on annotations, just kind of showing you the power. So for example, I could also add XML annotations. I know XML is not as popular anymore, but if I wanted to, I could say XML first name. And now if I exported to XML, the node for this particular field will be called first name. And likewise, if I were to consume this data, if I were to try to unmarshal some byte data into this struct, it would take the nodes or the JSON fields and it would map them appropriately. So I don't need to sift through all kinds of arrays and do all kinds of mess. It does it all for me, which is particularly powerful. I know if you're looking at say JavaScript, it's already pretty easy to handle JSON, but I think in no language is it easy to handle XML. And likewise with CSV, if I wanted to do CSV, if I wanted to say use MongoDB, I could use bson. There's a whole lot of different annotation types that I could use. One more thing on the annotations before I progress out of this. You could also do, there's some properties that you can assign on them. I don't know all of them off the top of my head. I only particularly use one. So omit empty, you'll notice that I have a comma there. So basically what I'm saying is if this field is anything, if this field is the default value, which would be an empty string, it's not going to be included as a JSON property. So it's up to you on how you want to handle that. A lot of times maybe you don't want the field to show up if it's empty. Or maybe you do. Maybe you want it to show up as an empty string. That's up to you. Omit empty is saying that if first name is not set, it will not show up. And I can show you that by commenting this out. And I can run it and see how it only shows last name versus if I remove it, it should show an empty string. Yeah, so an empty string. So just something to note that you do have that power. For logistics reasons, for people who are joining late on the stream, this is kind of an introduction to Go. We don't have a particular project in mind. This is just a request that I get a lot when I'm out and about. People have heard of Go, but don't really know how to get started, or they don't. It might seem a little complicated at first glance. I'm trying to ease everyone into it, make it a little easier. So this is live. Please stop me if at any point you have a question. I'm here to help. All right, so let's keep moving on here. That was, I know I jumped pretty quick into the whole JSON thing and double return values for functions. But let's maybe dig a little deeper into functions now. Let's create our own function. So we'll probably start with what you probably see in every tutorial is maybe a basic addition function. So what I can say is I can say function, and I can say maybe add, and provide it some data types. So let's say we could say A, we could say I prefer value 1. This is going to be an int. Let's go ahead and say value 2 is also an int. If I wanted to, because these are both ints, I only need to define the second one because they're the same. But I like to spell them out anyways. It's throwing an error at us because we haven't finished it. In this case, for now, I'm not going to have a return value. I'm just going to do my business directly in it. So this, I guess you can think of it more as a method for now. But I'll say fmt.println, and I'll say, let's go ahead and say maybe value 1 plus value 2. I think println will accept that. Let's save it. No error, so it looks like it's probably going to work. Let's go ahead and print it out then. So let's say not fmt. Let's go ahead and say add. Let's go ahead and say 5 and maybe 3. So I saved it. Again, this is probably a lame example, but it's an example that works. So I'll run it, and it said 8. So that's what we expected. So let's go ahead and change it so that way it has a return. We're going to say we only want one return value in this circumstance. So I'm going to say that we're returning an int. Instead of printing it out, let's go ahead and say return. And let's run it again. It didn't do anything. So I called add, but I never did anything with the return value. So I don't need to accept the return value here. I can just ignore it like I did now, or in this case, forgot. So in this case, I'm going to say sum equals add. So because this returns an int, sum is now an int. So let's go ahead and print it out. fmt println, and I'm going to say sum. I'm going to clear it. I'm going to run it, and we have 8. So far so good. So let's go ahead and change this a bit. This is gonna make no sense at all. You probably would never do this in reality, but I'm gonna call this now do math, and instead of returning just one int, I'm gonna return 2 ints. Because in Go, like I said previously, you can return numerous values. So I'm going to save it. It just added a value there for the temporary. Let's go ahead and assume that the first one, instead of an addition, let's go ahead and say that this is value 1 minus value 2. So the first return value is going to be a subtraction, and the second return value is going to be an addition. So let's go ahead and try that out. So this is going to be called do math. So the sum is the second value. Let's say the sub is the first value, and let's print them out. So this, I'm going to change this to a print format. This is going to be let's go ahead and say sub is percent, and like I said, I always use v. The correct one for int might be d. I don't really know. V works in most scenarios for me. So sub is that, and let's go ahead and say sum is percent %v. We're going to say new line, and we're going to say the first one is going to be sub, the second one is going to be sum. So let's go ahead and give it a shot. So I run it. So it says the subtraction of 5 minus 3 is 2, and the addition of 5 plus 3 is 8. So far so good. So there are plenty of reasons why you would want numerous returns. This is not one of them. Typically, you're going to have numerous returns. One's going to be an error, and one's going to be your actual desired result. So that way you can do error checking, because error checking in Go, it's going to be different. The way that you check for errors in Go, as far as I know, try catch blocks are not available in Go. So it's just how you do business is different. You're going to be finding yourself doing a lot of this, and that's fine. That's just how Go operates. So let's go ahead and try something else. And actually, there's one more thing I can show you that's interesting. So I actually returned 2 integers here. Let's say that I'm not interested in the return value there. I can't just go down here on line 31 and remove it because we're returning 2 values. What is sum going to be? Sum is, we don't know. So if I'm not interested in the subtraction, I can have an underscore there. So an underscore means that I'm not interested in the subtraction value. I can delete it. I'm going to change this up a bit, and I can run it. Oops, I'm doing that typo again. And this time around, it's only doing sum. I know a lot of people, especially myself, because I am one of the lazy developers. I like to underscore a lot of errors. Don't underscore your errors. Don't be like me. Catch your errors. Do something with them. Don't just underscore every error and hope it works, because you're going to have some bad code. Let's check the chat real quick. Perfect. Notice that there's quite a few people in chat. If you're new to this channel, please drop it a follow. Follow the channel so you get notifications. My goal here is to help and to engage and hopefully make everyone more confident developers. So the whole goal here is to get you started with Go. So hopefully by the end of this, going to give it maybe 15 more minutes, and then you feel a little more comfortable with Go. What's next? What should we do next? So we have function. There's more that we can do here to functions. So for example, let's go ahead and add another function here. I'm going to say function. This time around, I am going to kind of add a function to a data structure. So the best, I don't know if this is the best way to explain it. Coming from being a JavaScript developer, at least old JavaScript, where you can add, you can work with prototypes, where you can add functions to, say, arrays and things like that. This is kind of how I relate to it as. So if I wanted to add a function to person, what I could do is I can say person, and then person, and then I can say maybe toString, and I can say that's it. So if I wanted to, I can say fmt print line person, or even better, let's go ahead and say instead of print line, this is print f. This is going to be %v and %v. Notice I added a space in there. And I'll do a new line. And we'll say person dot first name. And we'll say person dot last name. So what this is actually going to look like is if I go down here, I've already got person. Let's go ahead and uncomment the nick part. Let's go ahead and actually I'll remove some of this. We don't need it anymore. What I'm going to say is I'm going to say person dot toString. So you'll notice that it's there in the list now. So I'm actually passing in my person data structure to this function, and it's going to do its business. So I'm going to say Nick Raboy. So I guess I don't know if you can actually say it's passing it in, but it has access to the particular variable that this function resides on. I can always create function parameters or function arguments to pass in this as well. I could also set it return values. It could be exactly like this. The only difference is I am now adding it to this particular data type. So it can be quite valuable. Probably not so much on the toString aspect of things, but it could be valuable in the long term. So please stop me if you have any questions. I'll add in the chat too. Take a quick break real quick. If you're late to this particular stream, don't worry if you've missed a lot. I'm going to be putting it up on YouTube after. It may not be tonight, but at some point in the future, it'll be up on YouTube. So just go ahead and catch it there. Although, please, it would mean a lot to me if instead of just always waiting for them to show up on YouTube, be a part of the stream. Just watch them when, if you're available, hop on, sit in, chat with me. It's more fun that way when we have some engagement. All right, so we looked at what we can do with functions. One aspect of Go, and this is probably my least favorite aspect, but only because this was my least favorite aspect of C and C++. So Go, if you want to, you can make use of pointers. So pointers, while powerful, can, if you're like me, they'll really throw you off your game. So I won't pretend like I know what I'm doing when it comes to pointers. But let's say, for example, I wanted to change this. I think this is valid, potentially. So what's happening here, at least what I think is happening, because I'm so bad at pointers, and I just cross my fingers every time I try to use them, is that instead of passing, or I'm working with a pointer, the reference to this particular variable instead. Again, I'm not going to pretend like I'm a pro when it comes to pointers. They work. Sometimes the libraries require them. Sometimes I find myself using them. But for whatever reason, I haven't spent enough time really knowing them. So I won't get into that too much. One thing that I did want to show is if I go to my web browser here, and I'm sorry if I just blinded you. It just blinded me for sure. There is a Go tour website, so kind of a Go by example website. So this is an interactive experience for Go. It's quite lengthy. I'll just click through some of them. It talks about pretty much everything you need to be successful. And at some point it'll have a lab. It'll walk you through. It'll kind of challenge you. You'll enter your own code and try to get the correct answer. But it's a great way to get started with Go. It'll teach you the language. From then it'll be up to you if you create something awesome with it. But it does teach you the ins and outs. So let's see if there's anything maybe that I particularly wanted to show that is a big deal. think there's a table of contents. So let's go ahead and check it out. I mean, there's loops. I didn't really go over loops. So the concept of loops in Go is a little different. I actually got my first introduction to Go loops by using Hugo, which is what I use for my blog. So my blog is this. So Hugo is created with Go. It's a static website generator. The template engine for designing themes for the blog uses Go templates. So it's kind of like this kind of exotic version of Go. So it's like inlining Go into your HTML. It's a little weird, but it's not bad. So for example, let's go ahead and go back to let's go ahead and maybe go back to a slice example. So let's go ahead and say we'll go back to data. This will be a slice of string. We're going to say data 0 is going to be, and actually what I want to do is I want to say data equals append. And then data equals append. And we're just going to do a loop. So let's loop through that data. So we're going to say, first of all, we'll do a typical as you kind of would expect for loop, which is pretty consistent between the languages. So I'll say for I equals 0, and notice the colon. I'm going to say I is less than, I can say data dot, should be able to say data dot, no, it's different. So it's len and then data. So that'll give me the size of that slice. And then I'll say I++. And you notice there's no parentheses there. I'm just going to say fmt.println, and I'm going to say data I. So this is something that you would expect in every language. Not so bad so far. I'm gonna take a big turn in a second. So not bad. That's to be expected. Another way we can do this, and this is kind of like a for each loop in a lot of languages, but we can say for index. So index. This is a multi-return kind of loop. So we have index, and then we have, in this case, maybe element. I'll say E for element equals range, and it's going to be a range of data. So it's going to be kind of like a for each loop where we have the index that it's currently on, as well as the particular element. So if I wanted to, I can say fmt.println, and in this case, I'm just going to say E. I'm not using I. If I wanted to use I to print out the index, I could. In this case, I'm going to underscore it because I don't want to use it, and I don't want that error to persist. So I'm going to say go run main.go, and it's doing the same thing. So not too bad. I could also do loops that never end, which we won't play around with here. But in this case, this loop would be infinite until I it's somewhere in my code decided to break out of it. And there's other ways to do it. So you don't have access to a while loop or I mean a while keyword or a do while keyword. It's all going to be for and range in Go. One thing that I did mention earlier with the whole error stuff. So I mentioned the panic versus the log.fatal. So I did want to brush up a little bit more on that. So let's see if I can undo in my terminal so that way I don't have to type everything out again. I want to get that person data structure back. That's good enough. So I'm going to wipe this out. So we have the person. this is capital F now, capital L. We're not using it. What I want to do is I want to do the JSON Marshal thing again. So I'm going to say data error equals JSON dot Marshal. This is going to be person. I'm going to try to catch this error. So if error not equal to nil, and I'm going to say panic, and I'm going to say error. So this, and then finally, of course, I'm going to say fmt dot print line, and I'm just going to say string data. So what I want to demonstrate is the value of panic. So like I said, you could do some kind of cleanup code when your function terminates. That's through the use of a defer. So a defer, you would place it somewhere in your function. It doesn't have to be the last line, but when the function terminates, any defer statement is going to be run. So for example, if I wanted to do some cleanup code here, and this error is thrown, this cleanup code is never going to happen because it's going to terminate. But if I do a defer statement up here, anywhere above it, that will still run because the defer has already happened. So this print line is not going to happen, but because it panics, it's still going to happen. So let's go ahead and try it. So typically we would defer some kind of function. So what I think I could do is make my kind of own function right here. It's been a while since I've done an anonymous function in Go. Let's go ahead and try it. Sometimes I get mixed up between JavaScript and Go a lot. So this is going to be an anonymous function. So if I wanted to, I'm going to say fmt.println ending the application. So if I were to run it, what it's going to do is it's going to print out hello world. It's going to print out data. And then it's going to print out ending the application. It's not going to fail because we have proper JSON here. So let's go ahead and try it. So it did exactly what I thought. I'm not sure if I could marshal some malformed JSON here. It's more likely to fail if I were to try to consume it. So I'm not sure I can force fail it. Maybe I can, instead of this, maybe I comment this out and I say panic. So I panic. Data is not going to be reached, but let's go ahead and change this to person. It still shouldn't be reached. It's probably yelling at us because it's unreachable. It knows that it's unreachable. Let's see if it still runs. Yeah, so it still runs. So let's see. Yeah, so it printed out panic. It also ended the application because of my defer, but it didn't print out the actual JSON data from person. So it's pretty cool, and you can have multiple defers. Usually you probably wouldn't do an anonymous function like this. I mean, you could. There's circumstances where you would, but just create your own function. So it is 8:00 p.m. here. I think I may wrap this up. I don't know if anyone's still watching or not. It's been kind of quiet in the chat. Let's go ahead and maybe do some logistical stuff here. So this is a live stream on Twitch. If you're watching it on Twitch, I definitely appreciate it. Please, if you're not a follower of the channel, please hit that follow button. It's much appreciated. Take a visit to the blog. I'll add that link again. I think it's still in the chat on the screen. I don't know if the chat's too small to read on the screen. I may have to increase the font size. The next stream is actually going to be on Sunday. So it's going to be at 2 p.m. Pacific time. I'm going to have a guest on this particular stream, and we're going to be talking about AWS. API gateway. Sorry, it's late. I'm drawing blanks. I've been up a long time. API gateway. So that's going to be Sunday at 2 p.m. Pacific time. So I'm going to probably try to alternate between solo streams and guests on the stream. Try to keep it exciting. If you have ideas on what you'd like me to stream about, let me know. I could very easily keep going on about Go. We could actually start to build a project together. It might be interesting. Totally up to ideas. But yeah, I just want this to be an interactive experience. It's going to be a little different from the YouTube channel. This video will be up on YouTube. Hopefully it provided some kind of value to the newbies. But other than that, I mean, thanks for tuning in. Catch you all later. Have a good weekend.